Rivian changed its navigation and route planning from Mapbox, the open source system it built its own UI upon, to Google Maps, and I'm delving into it. I decided to check the implementation, with route planning being a personal interest. With a 12.3 inches instrument cluster on top of a 15.6 inches landscape oriented center display, the opportunity is enormous for Google to spray its highly effective simplicity. I have sampled Google's work in the GM cars, as well as its more advanced efforts with the Volvo and Polestar Duo. With Rivian, it could go a further distance with Rivian's highly respected software teams. So let's get into it. Let's start by entering a local address first. The keypad pops up instantly and starts accepting the input. Entering the address, the predictive text or autocomplete gets started on it and delivers the list of addresses to pick from. The desired address is right on top and it's recommended two possible routes. Details of the destination emerge, like pictures of the place, its hours of work, and available chargers. That's interesting. A card at the bottom displays the distance, time on arrival, and time taken to reach, arrival range, and state of charge. Next, let's check a long route. Let's look at the Joshua Tree National Park. Again, it's mapped the route and has added 3 charging stops. Expanding the list displays the chargers and Rivian's charger rating system for DC chargers, marked in yellow and green circles here. It's straightforward, on A being the highest reliability and F being the worst. The grades are based on average top charging speeds, the payment success rate, and an overall session success. Further, you see the actual charger availability, available amenities, and other information. That's expected and a thumbs up. That also demonstrates to me some useful collaboration between Rivian and Google developers, and not a mere outsourcing relationship. We need more of that across the OEMs. And it's also conveying to the user how it rates the chargers. Reliability of public DC charging has been a huge impediment for EV adoption, and this should alleviate the problems somewhat. A great route planning experience goes far beyond just plotting a path on a map. The best systems are thoughtfully layered on top of robust navigation engines and intuitive maps. But that's just the foundation. What really makes a difference, especially for EV drivers navigating busy roads, is how the information is surfaced. Let's look at another destination, the Yosemite National Park. Crucially, drivers often have only a fleeting moment to glance at the screen. That means important route details must be clearly visible, ideally integrated directly into the instrument cluster, or placed on the periphery of the center display where the eyes naturally flick. It's not just about beauty, it's about safety and usability in real world driving. One reason I like Tesla's basic white background layout and why I dislike the missing cluster in the car. Another key feature often underrated is lane guidance. In dense urban traffic, knowing which lane to stay in can make or break a smooth drive. These cues need to show up promptly, if not slightly ahead of time, and be large, bold, and brief. No one wants to decode paragraphs when merging into traffic. At the corner is the button to view chargers and a gear icon to set your preferences. Things like preferred arrival range, avoiding tolls, ferries, etc., avoiding charger locations that require an adapter, and your preferred charging networks. Some are common features long known to Tesla drivers, while some are features important for cars that need to handle a difficult public charging environment. As we build towards smarter and more driver-aware navigation, these small but critical UI elements can greatly improve the driving experience, making routes not just more efficient but far less stressful. Let's look at one more destination here, the San Francisco International Airport. The processing of all of those requests has been satisfactory, and all are pretty standard. As EV adoption rises, another issue is emerging: charger congestion. Route planners must evolve to include the ability to secure a token or spot in a queue at charging stations. It's no longer just about routing to a charger, it's about minimizing wait times and planning smarter stops, especially on longer drives. This is particularly so as EVs grow in numbers and the infrastructure takes time to catch up. I already see several non-Tesla cars charging at Tesla superchargers. Assigning a place in the queue would be a timely feature at this point. Let's now look at the differences in the underlying system. The previous Mapbox system was a Rivian UI built on the Mapbox SDK, running on a Linux based system. The new Google system is Android based with a native Google Maps engine. I was told by Rivian that all the cars have now been updated to the new system. The Google system almost immediately displays higher accuracy on routes, detailed lane guidance, and enables multi stop route planning with EV relevant factors. Though important things like actual charger availability are network dependent. And with Google, you get real time traffic updates. Charger stoppages now shift to Google's algorithm from Rivian's. The new system delivers better battery aware routes, though to me it still seems like a work in progress. These include things like real time range estimates, state of charge on arrival, charge speed, and availability. The charger filters, a feature Tesla users never really need, with their own network so dominant, are very effective in the Google system in Rivian. The big one is trip energy modeling. The new Google system significantly improves the simplistic elevation and weather modeling that Rivian previously had. This is a very critical area, and Tesla is still the gold standard. The previous system only displayed turn signals and a mirrored map on the instrument cluster. The newer system displays the ETA, lane, and turn indicators with clearer visibility. I couldn't make out any major differences in the voice navigation, but with search, Google naturally unleashes its vast data, like points of interest, hours, reviews, pictures of places, and more. The responsiveness also seems better, though not something that I could distinctly notice. The things we'll need to watch for are the speed and agility of OTA updates, features that could now arrive through better phone integration and with access to the Google App ecosystem like the Play Store, YouTube, and more. The Trip energy modeling system seems very similar to the Tesla approach. It overlays custom EV energy predictions on top of Google's routing engine. That enables relaying real time estimations of the battery state of charge at the end of trips, all inside the route view in addition to the directions. There are several factors that go into the model. I assume the system does not yet account for the car's tires and aero profile, but it starts with driving speed and route type, like driving in the city or on the highway. It adjusts for the terrain, related elevation gains and losses, along with payload and towing. Finally, the use of HVAC, outside temperatures, and traffic conditions complete the model to predict the accurate state of charge at the end of a trip. Rivian's own model works further on those inputs, much like what Tesla's does. The system has a significantly dynamic element. The energy graph adjusts in real time as your trip progresses. If you encounter unexpected elevation or drive faster or slower than predicted, the remaining range and state of charge at the destination get updated continuously. For the user, the system displays the route, multiple ones if available. It projects the state of charge on arrival and adds charging stops if required. It also provides an energy graph that shows the predicted energy use against the actual, along with possible drop-off points. When adding charging stops, the system considers preferences, plug compatibility, and real-time availability based on the network, optimal charging speed, and time. Rivian adds its own value by adjusting the model based on user-selected options like driving in snow, towing, and payload. And most importantly, the model also accounts for adjustments due to regenerative braking. Route planning faces several challenges. Problems like static routing assumptions remain common. These systems often struggle to adjust to sudden road closures, accidents, and general congestion, which affects their ability to recommend optimal routes. Most models also struggle with accurately predicting energy consumption, and it's well known that their estimates are not completely reliable. The issue of static assumption gets worse when it comes to charging infrastructure. Only Tesla provides live charger status updates, and even those aren't always reliable. Most systems have difficulty accounting for broken chargers, plug compatibility issues, and the actual performance or condition of charging locations. I have seen systems recommend too many charging stops, often without much thought given to the actual locations, like chargers placed behind malls that may not be safe during odd hours. Wait times at chargers are a major factor, and yet there is little to no support for this from the charging networks themselves. Losing connection or going offline can be a nightmare, especially in remote locations like mountains or rural areas. Even basic map functions can break down, and there's still a lot of work to be done in improving offline navigation support. These systems also struggle to account for real-world driving variables, like individual driving style, road surface quality, and seasonal conditions, all of which have a significant impact on energy consumption and route reliability. Despite the advancements, in-car software UIs still suffer from issues like small text, poor contrast in sunlight, and occasionally distracting animations. There's a huge opportunity to better tailor these systems to the specific vehicle they are running in, adapting more closely to each vehicle's dynamics and real-time feedback. Customization is another area where current systems fall short. Drivers increasingly want to choose their preferred arrival state of charge, and routing systems should also offer options based on preferred speed, scenic routes, or charging networks. Right now, most systems still operate with a one size fits all approach, which limits both efficiency and user trust. So, that was a look at Rivian's new Google Maps based navigation system. Definitely a big leap over the old Mapbox setup. It was also good to put in perspective the demands of the space, its challenges, and actual value the new Google system achieves over the older one for Rivian. With richer real time data, better visuals, and smart energy predictions built right into the route, it offers a much more polished experience. That said, when stacked up against Tesla, with its tightly integrated charging, highly accurate predictions, and super intuitive interface, there's still a noticeable gap between the leader and what's easily the second best system out there right now. Let me know your thoughts in the comments. And if you're curious, check out my recent videos on the Lucid Gravity and the delivery day inspection of my own brand new Tesla Model Y. Links are in the description. See you in the next one.